Welcome to all. So we were discussing on some examples of point groups. So we were stopped last that I think cyclopropanes we are discussing. So two more examples, important examples is there. One is trigonal bipyramidal. Trigonal bipyramidal. So here that is you can do as TBP. Can check? Yes. So trigonal bipyramidal. So how the structures actually look like? Says let's say this is M, then 3, and this is in equilateral and two the axial. Let's say this is A, and A. These are, let's say like this, and again here is A. So three equilateral bonds are sent at the same time. Two axial bonds are sent. Okay, so now if I talk about a bit, then what I said here, if we talk about of the point groups, then what are the point groups are present here? So if we say, then if you pass that point groups, then C3 axis is there. If and here that if I pass the axis here, then passing through A and B, then this are get or replaced. So 3 C3 is there. After that, what I'm saying that if I pass the one planes here, then this get replaced, this replaced, means C2 is there, and one C2 means 3 C2 is there. Similarly, if I pass the planes here, then also this get replaced. So 3 sigma B is there. Also, you can say that the C3 axis and this, if a plane passes through plane passing through this and this and this, so if plane is like this, so if plane pass like this, then this C3 is perpendicular to this plane, so sigma is also there. So if this point group says that this is, so sigma is, then S3 also there, C3 is there, sigma is there. So this is the DH point groups. So now this is the case 1. Now if I let me the case 2. If I replace that atoms from any axials, okay, so if we replace atom in equatorials, if I replace, then let's say M is there, so this and this. So here A was there. Now I would like to put one B here, another is A here. I replace A with B, and here same A is there. So in this case, if you look that, so in this case, we see that C3 axis now is present, and C3 axis now is not present. Okay, C3 axis is not present. So, but if you look at, then sigma is present. So if we pass the planes here, cutting this B and M, then this get replaced, this get replaced, means sigma is there and sigma is there. Okay, and with that, what is there? C2 axis is there. So if you pass that axis through this, so this get replaced, this get replaced, means C2 is there. So C2 is there, then 2 sigma B, because C2 is N sigma B is there. So this is the molecules of sigma H is there, because sigma H is whether sigma H is there or not. So C3 is absent, past C3 is absent. So now the principal axis is C2. So if you pass this, then that C2 also the same directions. This plane is this directions, and C2 is also this direction. So sigma h is absent. So these point groups will lie in. So what are the symmetry elements is there? E is there, plus C2 is there, plus 2 sigma b is there. So this is the point group of C2b. So if we replace one atoms in axial position, then the point group changes from D3H to C2b. Okay, so similarly, if I replace, can you replace the two atoms? Let's say then I want to replace two atoms. So let's say here I put B here, I put B here, let's say A, and here A. So this. So what is the point groups in these atoms? So if I look at, if I pass that planes C2, then this get replaced, this get replaced. So C2 is present, and E is always present, and this is also sigma B is also present. So 2 sigma B is present, and here C3 not present. So again this is C2b point group. So if you replace by 1, or if you replace by 2 atoms, then also the point group is same, C2b. Okay. So now if you replace all the threes, then again if I replace M by all the three, let's say this is B, let's say this is B, this is B, and let's say this is A and this is A. Then in this case, E is there, plus C3 is there, plus here C2 is also there, so 3 C2 is also there, also sigma is also there, also S 3 also there. So this is again going to be the D3H point groups. So if you replace all the three, again you get the D3H point groups. So now if you replace in axial, then what happens? This is M. Now I am replacing that here B, and this is A, this is A, this is A. Then what the point groups, how the point groups will look like? So for this case, we can see that so if I pass the planes through this, then C3 is there, C3 is there, E is there, and sigma is so if you pass that any this, then this will get replaced, but this and this will not replaced. So you can pass the sigma is absent here. Molecular sigma also passing through 3 atoms also not with there. So sigma is not there. So point group is C3. Okay. So if you replace both, then again we will get the same. Okay. If you replace both B, then it's same like this. So again we will get D3H point groups. So now we will go to the another important geometry, that is octahedral geometry. So octahedral case, how that unlike that here that 4 is there, and these all are same, these all 6 bonds are same length, like it says A, all 6 bonds are same. So if you change any directions, then it will be same, because all bond lengths are same. Okay, so now for this is highly symmetric point groups, that is octahedral point groups. Okay, so that we have discussed that the highly symmetric group with highly symmetric elements, symmetry operations, that is octahedral point groups. Now if we replace then the atoms, then how it will point group change. Okay, now if I write here, let's say here A, and let's say here B I replaced. Now this is A, this is A. So either here or this is same with, if I write B, same, because all the bond lengths are same. So this is also fine, this is also all are same, because if you replace either here or here or here, all looks the same, because all the 6 bonds are same. And by changing that with the conformations, means the rotations without breaking bonds, then the point group remain unchanged. So here the point groups is whatever, here the same, here will be the same. So what is the point groups here in this molecules? Point groups, I will say that. So if I pass that C4 is there, so if I pass this by using this and you will cut, then this 4 are same. So C4 is there and E is there, and what things are there? So if I look at the structure, then let's try to visualize it. So these atoms, let's say this 4, I think so these 4 atoms are like this. So this is also same. I assume this is also black, this is also black. Okay, so now if that one is coming here, this is the difference, and this is also black. Let's say this is also black, and one is coming to here. So if I write here, here also one is black is there. Let's say so let's say these all are same. So these all are same. So one is here. So if I rotate, then C4 axis is present. And now what I says that C2 axis is present or not. So one thing here, so you're looking like this, C4 atom is there, and this is difference, this is difference, and another is same. Backside is same. Then if we pass that, backside also same. Then if I root C4, then this all will exchange. So C4 is there and C2 is there or not. So these atoms, so if I pass that C2, then this and this, then this and this and this get interchanged. But that C2 is, I have to apply these directions only, because if I apply C2 here, so I have to apply C2 here only, and C4 also this directions only, because if C4 if I apply from this direction, then only you get. But that for dihedral, like let's say C4 and for C2, and this C4 perpendicular to for C2, then we can say that dihedral DN or D will come. But here what we see that if this is the 4 atoms, now C4 is applying these directions, and C2 if we apply from this direction C2, so let's say if I apply from this direction, then this is perpendicular, this is C4, so perpendicular this will C2 and C4 will be perpendicular. But here if I apply C2, then this is there, so C2 is not present. So if I apply C2 from here, then only that C2 is exist. So the here that C2 is there, but that is not perpendicular to C4. So C2 is there but not perpendicular to C4. So and for sigma B is there, but if you apply that any directions, if you apply here, if you apply, then this due to this, and another is here, but this is same, but problem is that this is the difference. So if you apply C2, then due to this we will not get C2 axis. So C2 axis you have to apply by these directions only, then only you get the C2 axis. So here sigma h is not there because this is difference and below side is different. So this is falls in C4B point groups, not D, because this C4 and C2 is not perpendicular. So this falls in C4B point groups. So next case, if I talk about of case 3, then let's say this is M. Now I replace the two atoms. Let's H B and let's H B. All are same. So now I will say that this is A, and A. So if I replace, so one thing that these are the planar. Okay, so one thing here that so either this is also fine. And if you apply this, so C4 and C2 is in the same direction, that's why that D is not present here. But now in this case you see that again these are same, so C4 is there. Okay, now C4 is there. In this case C4 is there and E is there, and we can say now that if we apply that C2 this directions, then C2 is there and C4 is this direction. So now this C4 and C2 are perpendicular. So C4 C2, that is for C2 perpendicular to C4. So this is present now, and here we can say that sigma h is also present and for sigma b also present. So in this case this is again lie in 4D for H point groups, but this groups, since this 4C2 is not perpendicular to C2 axis, or C2 axis is not perpendicular to this 4C2, so not D is present, only 4CB is present. Okay, now case 4, that is facial isomers. So how the structures look like? So let's say here M, facial isomers, it looks like something, let's say here A, um, A and A, and here B, B, so that is, I will try again, facial structures M, let's say A, and let's say here A, and let's say here A, and another is, let's say here A, and so let's say here this is B, this is B, and let's say here this is B. Okay, so because and this same A is in one sides, the four facials, and this B in one face, so this four facial. So these facial structures, this is, we can draw that, I can draw this one like this. If I draw like this, so if I draw A, just I tilted it, I tilt like this little bit. So this A, this is B, this is B, this is B. So this is, let's say this. So now so sorry, B, this structure. So this we can assume as same as NH3. this structure we assumed as NH3, like one is H, and here H, and here H, and here is the lone pair. So same things we can assume that special we assume as ammonia. So this is the equal to C3b point groups, like here C3 is there, that is passing through this, and 3 sigma b is there, and plus A is there, so that is C3b point groups. Okay, so this is C3b point group. So you can say that partial ammonia partial. You can say that ammonia partial. Okay, so this partial structure has like ammonia. So now we will study that second types, that is third, fourth, and fifth. Fifth types, this is that is partial. Another is meridional. Meridional structure isomers. This structure is like, let's say M, and let's say here A, and let's say A, and let's say here B, and here A, and here B, here again B. Okay, so these structures, so what that between this A, this is 120 degree, and another between this 120 degree and this is 90 degree. Okay, so two angles between 2A, one is 180 degree, this is 180 degree, and 90 degree. So this type is there, then meridional. Okay, so these structures you have to remember that this is like H2O point group. So H2O point group has C2B. So this meridional is the point group of C2B, that you have to remember. Okay, so some more that special things we will discuss, that is, let's say if the questions is given like C, and CS3, and says that H, what is the point group? For this case, this is C infinity. And if the question is simply given that C3H4, so what is the point group? Then here in this case will look like CS3 will look like CH, H, H. So in this case the point group is, this is same like ammonia, so point group will be C3B. So you have to remember that in which way the questions is asked. If questions given this structure, then we have to if in questions given this structure is given, then C2B point groups. If not given, simply written this formula, then we have to draw like ammonia structure, and that structure is C3B point group. Remember that if that particularly this is mentioned, then you have to do this, and if this mentioned, then obviously you have to do this, and if simply this is asked this question, then we have to draw like ammonia, not these groups. Okay, so this is sometimes get confused. So C3H4 is written, then draw like ammonia, and if structure is given, then we have to go like that. Okay, this is you have to remember. And one more point groups we will discuss, that is B2H6. So B2H6 I will draw B, let's say H, B, H, H, H. So this is the B2 structure. So this also we can write. We can write like B. We can do above H, B, and we can write H. So since I not just do the below and above, I just rotation. So here that point group, this point group is same, because rotation is that breaking bond, then point group remain unchanged. So this is has same point groups. So if you look this structure, what you notice that if I pass a axis, C2 axis, then what is that there? This go below, this go above, this will extend, this will interchange, this extend. Means E is there first and C2 is there. And anything like again if we pass this here, then also this and this get interchanged. So n number of C2 is there, that is 2 C2 is there, 2 C2 is there. Anything is there, so I will write like this: E is present, C2 is present, 2 C2 is present. So similarly the sigma B is also there, because if I pass this sigma, then this get interchanged, this get interchanged. So plus 2 sigma B is there. And also that sigma H is also there. Like if you say that passing through this and this, then this here, that C2 is the principal axis, and that the plane passing through these atoms, like this is like something like, we can say that front below, and this types is our this H is fronts, this is this and this, these are front H and these are back H. So another H is something like this, and below and here this like this. So if that plane is this directions and C2 is this direction, they are perpendicular, so sigma H is also present, means sigma H also present. If C2 is present, sigma is present, then S2 is also present. So this point group is D2H point groups. So this is in the point group of D2H, and S2 means that is equal to I. Okay, so this is we have practiced some examples. So we have for more clear, we have to practice more. So from my side, this up to this. Thank you.